Hi there, this is Calculus Integrals, and the topic I'm going to be talking about is indefinite integrals. Essentially no finite range of x, but or no defined range of x, I should say. So, let's just start off. Basically, they're all going to be similar properties, but I just want to kind of draw this out so that we don't get confused later on. F of x equals c integral of f of x. Notice how I'm not putting anything on the top or the bottom of the integral sign anymore. It's because it's no longer necessary. We have no bounds. Okay, so integral of the whole quantity f of x plus g of x is the same thing as integral of f of x plus the integral of g of x. Okay? It's going to be the same thing for subtraction, so I'm not even going to touch that. Let's do something a little bit different. How about I show you a little concept? What if we had a integral of c dx? Okay, now remember that used to equal, between the two infinite points, you used to be able to determine what dx would have equaled. I'm sorry to say that that's not how this is going to work anymore. I'm going to tell you what the answer is, and then I'll explain it later on. Okay, so you have cx, and that's just from that power technique that we're using in antiderivatives, where you add 1 and then you divide it by the sum of the exponents. But then you also have to add a constant. Now, why do you need to add a constant? Now, this is not the same constant. I'm going to call this k, actually, so we don't get confused. Why do we need to add this constant? Now, just recall that what if you did d dx, what if you took the derivative of cx plus k? Well, you would have c, and actually the k would drop out because it has no x attached to it, right? So what we're trying to get a point across here is you need to add this constant, because it could be any constant and you could still get the derivative of c. And since the integral is antiderivative, you need to add that c, or that extra constant, this constant right here, you need to add that, because anytime you do an integral, there should be a constant, or there could be a constant added on to the end, because it would have canceled out from doing a derivative the opposite direction. So essentially, this is going to drop out once you take the derivative. That's the whole point. So to take that k into account, we add it in when we're doing an integral. Trust me, it's going to make things a lot more complicated, but the good thing is that usually they give you some kind of condition, like f of 0 equals a number, and they'll give you that, and you use these to determine your constants, which I'm just going to call k in this case. Okay? So anyway, let's continue on with the properties, because you'll realize that every single integral, indefinite integral, needs this. Okay? So integral of xn. It's going to be the same thing. X, you have n plus 1 all over the whole thing, n plus 1. Okay? But you have to add c. You have to add that constant, which we were going to call k. So let me add a k, actually. Alright, well, let's keep going. Keep pushing forward, okay? You got your integral of 1 over x. Remember that one? 1 over x dx. I should add dx behind some of these. Well, that equals ln of x plus our constant k. There's plenty more where this comes from. I mean, you could even take this. You could take this into your powers if you'd like. A to the x dx, that will equal ax e to the x power all over ln of a plus c. Notice how the plus c is always there. Just realize that that's constant, okay? I'm always going to forget that it's k in this paper, but just realize, plus a constant. The integral of, let's go into our trig functions, you know, sine of x dx is going to equal negative cosine x plus c. Keep going. And you could essentially just do this forever, really. I mean, integral of cosine x dx is equal to sine x plus c. The c is just a random constant, remember, not what we had above. Secant squared x dx. And sometimes what I do, if I am having a hard time remembering a particular one, I have these written down usually nearby, but let's say it's not really an option to have it written down, like if you have a test and the teacher doesn't want you to look at notes or whatnot, then I mean, what you can do is essentially just look at your derivative tables, or if you can memorize just the derivatives, then you can kind of backtrack what the integral would be, right? Let me just do one more. I mean, I could go on all day. There's tables upon tables of these, and it really, it's just, you just have to get familiar and comfortable with essentially looking up these. And actually, someone had asked me earlier, does it make a difference if I add or subtract the constant? And I said, well, what if you're adding 2 or you're subtracting -2? The constant doesn't really matter. It'll work itself out. The math will work itself out. So if you want to make your equation look prettier by having a plus rather than a minus, that's fine. Just realize that you're going to get, it's going to always correspond to what you put in there as a sign. So I caution you to it, but it's very possible you can do that. So let me see if I can do a quick example. Between 2 and 0, we have functions 3x squared minus x plus 9. What does that equal? Okay. Well, we got to do the derivative. Okay. First off, we have 3, which is the multiplier, right? Then x squared plus 1 all over 2 plus 1. And then you have minus x 1 plus 1 all over 1 plus 1. Then plus 9x plus your constant. Okay, well, this essentially can't, these two cancel out each other, this one and this one. So then you just have x cubed minus 1/2 x squared plus 9x plus c. Okay. Well, I mean, I'll be honest, usually between these you would have to you would have values, and you can determine them just from when it's definite. You can just determine them like this. You just, include it, and the constants will actually cancel out. But when you're indefinite, you will need a condition. And usually, like for instance, this one, if this was if this is f of x, then we would say that this would be f, capital F of x. So for a condition here, we could say that f of x, where f of 0 equals 0, then we would plug 0 in, and determine what c is. And in that case, c would equal 0. So then your total function would equal, essentially everything without it without that C. So I was just trying to show you that essentially the differences between definite and indefinite are very little, with the difference being that definite you have to evaluate it after the fact. So you would actually plug those two and that 0 in at the end. So I hope you enjoyed the video, and please leave a comment if you want more examples. I think I'm going to make another example sheet regardless. So you guys have a good day.